Welcome to this video gauge demonstration video looking at how you could use video gauge for bridge investigations. Today we're going to be looking at a bridge in the English countryside. You'll see the pictures of it coming up just now, and this is a 4-span bolted steel arch bridge. That steel arch is 770 millimeters high, and it's got a decent amount of rust on it, so some nice patterns for us to use on video gauge for tracking displacement. We've had two different setups for this structure. One looking at the underside, you can see the blue lines there from the riverbank, and the other looking at that front face set up on a road bridge about 45 meters away. So we'll just show you the software now, and the videos going through there. You see we have one wide angle view of the whole structure and then three zoomed in views looking at the individual bolted joints, and we tracked displacement underneath each of the bridge stringers, and we also looked at what was happening to each of those bolted joints to see if they were performing as designed. So we've slowed the video down, and you can see the coal train just starting to go over the top now, and you can see the displacements coming on. Those three graphs at the bottom there show vertical displacement at quarter span, mid span and 3/4 span. But as you can see on the right hand side, we're actually recording a lot more displacements than that, vertical and horizontal displacement under each of the stringers, just using the natural pattern. The resolution we're getting for those measurements on the wide angle view is about 0.2 millimeters, and we will zoom in a minute. We'll replay the video looking at the detail section in the midspan. From that detail view, we're about an order of magnitude better resolution. Just to prove that resolution, we'll now open up, and you can see root mean squared numbers all around about 0.2. So here we are on the detail view, and you can see that we've got that green box across the bolted joint, and that's a strain map showing areas of high and low strain. That's actually set up to plus or minus 2% strain, and you can see that the purple area is an area of negative strain, the red area is an area of positive strain. So as each axle goes over the joint, there's a small crack there which is being compressed, which is the purple area, and then as the flange moves away from the bolt, it's creating area of high strain, so there's some separation there, and that appears as a positive strain. So if you take a look at the graph on the bottom left hand side of the screen, you see an extension going to that 1.7 millimeters and then returning almost to zero between each axle. And if you look at the numbers at the top, that gives you a clear indication of what's going on. You see the 100 millimeter gauge length, you see the extension at the top. We've also plotted extension at the bottom, and that only gets to about 0.04% strain, so much less. And when the train has finished going, you can see that the RMS of those strain readings is about 0.02%, and the RMS of the extension is about 0.02 millimeters. So as you can see, video gauge can be used for wide area investigations, but also detail zoomed in views. Thank you very much for listening. Bye bye.